Hello, welcome to the RC Wallet Vacuum channel. Well, today I'm up here in a rather hot and humid shop to try to put some of the finishing touches on this dyno. And so I started doing some tests. I had to put it on the back burner for a couple of weeks due to some other commitments, but making progress now again. And so first thing to do is I'll take a look at the completed, mostly completed, I guess it is totally completed, circuit card, controller card, computer card, whatever you want to call it. So here's the completed and assembled control board. Surprisingly, for just something like a dyno, it's got a lot of shit going on in there. So this first microcontroller over here, this one is only has 3 jobs. It's going to read the throttle pot and then output to the servo. And its third job is going to be this RGB LED. It's going to be monitoring the power coming in and flagging the operator if your voltage is getting low. And that's because this thing is set to be able to run off of 5S LiPos if need be, and that'll tell you if your LiPo's getting down low. So that's the reason for that setup. This other micro over here is the main operational unit. It's grabbing power off, or it's grabbing signals off of the speed sensor, the Type K thermocouples, and the load cell. And it does all the calculations internally, averages out the exhaust gas temperature, stuff. All that data is sent out and calculated internally on that, and sent out as text file or text ASCII characters to this unit over here, which is the main computer. Like I mentioned before, that's an ARM-based processor, a Raspberry Pi setup, and that's only communication back with everything is through these 2 wires here. That goes to the I2C network, and all the data between this micro and RP4 is on the I2C network. And the other thing this thing does do is monitors this. This is the atmospheric pressure and it's barometric pressure, temperature, and humidity. Then up here are the 2 A to D converters for the thermocouples. Down here is the HX711 amplifier for the strain gauge. It's a 24-bit. This is a 5-volt power supply. It's a 3.3-volt power supply, and then there's the level converter. That's to protect the Raspberry Pi from the 5 volts. It converts it to 3.3 on the I2C network. This regulator here is strictly for the monitor. This regulator here is strictly for the servo. And then it's got a barrel jack for input, and then got a Schottky diode in there, and that's just there specifically to refocus on in there. This is in here specifically for reverse voltage protection. So if someone was to reverse connect and put it in there, nothing will happen. And there's some other support components in there. And right over here is the voltage divider and monitors the input voltage coming in. It's got some center protection, and that goes up to this microcontroller up here to the A to D converter. This here is an important component too. This is a potentiometer to adjust this regulator. This thing will run through, I think it's like a 4.5 volts up to about 2 volts below whatever your input supply is. I got it set right now to around 7.6, I believe, and that is to control that regulator for the servo. So you can adjust it for a 6 volt up to the 7.4, whatever, 8 volts for the bigger power servos. And right now I got it set to run a 5th scale servo and I think that's set for a 2S style, so that's why I got 7.6 or 7.8 volts. So I got all this stuff on board there, debugged and working, and now I'm just going to start bringing all the wires into it and then start debugging that part so I can start doing some tests. So I got everything roughly wired in here now, enough to at least test and see how that goes. I'll give this thing a quick fire up here. I got the power supply set, 15 volts. I got current limit of 3.8. I don't think I'll ever get to that point, but we'll fire it up and see what we get. Hopefully no fires. It's only pulling 300 milliamps. It's climbing. About an amp now, so the computer's probably firing up. Yeah, it looks like it is. Ooh, that's a good sign. It's still holding about an amp. Still holding. Oh, we got it over here. Oh, blue. Oh, there we go. I didn't like seeing that blue screen at first, but this is what I want. See the main desktop show up for Linux. Right now, the RGB voltage detecting diode is glowing blue. I gotta go in there and change it to at 15 volts. It should be green. All right, that's good. We got the Linux all the way up. So we'll see if the actual program works. Right now I'm just running it in the development environment. I haven't compiled it yet. I still got software changes, and I got to do extensive testing on this thing to make sure there's no bugs in it. And I'm sure there'll be prototypes. There's always issues. All right, at least the program's still in there. Let's see what's going to run. All right, that's a good sign. Yeah, right down the, floating around 1,000 milliamps in operations. That's not too bad. A 5S battery would run this without any problem. So let's see if we can get any, there will be no RPM and torque coming in just yet. Horsepower, obviously not, since I don't have either the RPM or torque. I should get something over here off the temperature, the barometric pressure, and humidity sensors. These EGT temperatures just come in as bullshit right now, too, because there's nothing attached to them. What do we get? Is it going to work? Yes, cool. Yeah, 89 for the temperature, 68% humidity. I believe it because it really sucks in here today. This is the guy that took it out. I had the same issue down here. I just got finished changing the software a little bit up there. See if we get any kind of torque readings out of this. Oh yeah, I've got numbers. So it's got to be calibrated. I'm going to have to reverse some wires down there too. RPM, I will not be able to read RPM right now because the software and the microcontroller that handles reading the RPMs will not work until it gets probably around 30 RPM, I believe, something in that range. So that looks good. The only thing I got to do is see if we got some. Yeah, we've got throttle servo going on. You can see it moving over there, but that's working, so that's encouraging. I got to play around with the parameters on that to get it to map correctly. And I still got to build a mechanical linkage there. Other than that, it looks like it's ready to go. Let me shut this thing back out of here. I'm going to shut her back down. So like I said, I got to do a lot of testing on this thing yet because there's always issues. I just got the hydraulics is mostly assembled. I reversed the pump today. I got a reversible pump because I didn't really know the end result. Which I played around with what I wanted. I'd be pushing the torque arm down or up. Finally decided on the up. Who knows whether it's the way to go or not. So that pump got reversed. All the other hydraulics are all in here. I just got to basically hook the hoses in, fill her up with oil, and get a throttle linkage over there, rig up a tank, and start doing some tests, and then the real problems start. Trying to debug it, do some modifications on the software, get the calibrations in there, and that kind of horse shit. But I'm going to cover that in the next video. I just want to do a quick update, especially for Advance and Wade if they're still interested in this thing. Although it's been so long, you guys might not be interested in it anymore. But I wouldn't really mind because I'm having a lot of fun with this thing, and I wouldn't mind playing with it here for a while anyhow. So anyhow. Thanks for watching.